All right, so quick review of what we did, right? So I gave you some steps on hypothesis testing, right? What were the steps, Nathan? What were the general steps that we did in the chi-squared? This was for the chi-squared. The first thing we did was what? What's the first thing that we did? Take a minute and look back now. The first thing we did had to do with developing the hypotheses, right? So for the chi-squared example, H naught was what? Right, no difference. So we will just write no difference. So now, in fact, let's put like no relation, right? Because it was a test for independence, right? No relationship. And then the H1 was a relationship. So if you remember, well, what we're doing in the test here is checking to see which of these are true. All right. And the way we determine that is by having a distribution. We know the distribution we're using. The distribution we used in this example, chi-squared. So we're going to use a chi-squared distribution, right? With some degrees of freedom and some significance level, right? The ones that we're going to do today will be different distributions, all right? So we use a particular distribution and then we create a region that we call the critical region. All of this here, right? This here is our critical value. This is our critical value. And anything beyond this value, we enter something called our rejection region. So the way this hypothesis testing works is that we are going to have to work out a value for the calculated value, or the test value. And if that test value falls inside here, then we force to say, here's what we're going to check this, right? So we are basically testing to see if this is correct or wrong. If it's wrong, we got to go with this. That's okay? That's the objective of hypothesis testing, right? We're testing to see if it's right or wrong. If it's right, we stick with it. If it's wrong, we got to go with the next one. That's okay? So these are technically opposites of each other. And this is A, or this is O, and this is O, right? So they are technically opposites of each other. And we always have to create something called a rejection region. A region that we're going to reject H naught and go with H1, right? So here's where we reject H naught. All right. And for this one, our rejection region was if chi-squared calculated is greater than the chi-squared critical value, which comes from this, right? So if a calculated value, which is what we have the formula to work out, if that calculated value turns out to be more than the value from the table, then we reject, right? We reject H naught at whatever level and conclude that H1 is true, right? Are you okay with that? And we learned how to do chi-squared calculated. What was the formula? Chi-squared calculated. We can look back. Sum of what? Observed values minus the expected values squared all over the expected value. Right? So if you remember in chi-squared, we had to work out the expected value. It was like we had to make an assumption. All right? And we worked out this and we practiced questions like this. This is the principle behind hypothesis testing. Right? All we're going to do now is we're going to change the different distributions. We're going to do a normal and a t distribution. Right? And that's what is that proportional, that binomial, and so on. So we're just going to change this now, but change the distribution. Same thing. We had to figure out H naught, H1. We have to figure out distribution, critical region, and rejection region, and then do some calculation. and conclude which one. Right, so that is what we're working with online and following. Right, this is the last thing that we have in the syllabus complete, right? After that, we're gonna start with, yeah, we're gonna start with, do past papers on the hand topics, right? And I'm doing all so that we're gonna have to do. The objective is to get some all in numerical skills to get it perfect. And by starts with SB, yeah? Yes, we had it full marks.
CS scholarships.
They are waitlisted. They have it.
There's no 14 or 14.
40. Who get the highest?
We teach us say your philosophy that for one say we teach us say you can help to the aspects.
That's important. Now you start there. Gotta get our hands on more. Sorry, I don't have much help left.
Yeah, that is something good. That's just
Yeah, I don't know how to pick up some, I don't know what's now. Okay, so cool, so I have to. One night, I think when I do one of them. How people put each other there. So close to each other.
What?
Alright, ready? Something here where to write down from alright. Ready? Okay, right, so the chi-squared. Chi-squared had a straightforward critical region. What is making other questions that this critical region is not straightforward? Right? After you read the scenario, you have different options. So what you see. Sometimes, let's say the mean mark, right? Let's say our mean mark, I am saying this, our mean mark is around 95. That's our mean mark in apply. We have three things that we can test here, right? Number one, we could test if our mean is less than 95. We could test if our mean is more than 95, or we could simply test if our mean is what? Not equal to 95, right? Some other pattern. So we have three type of tests that we can do.
Wait, so if the mean is like
If the mean is right, so that is what we are. Yeah, that is what we tested. Right? So if this is not true, either this could be true, this could be true, or this could be true. Right? So we have three options of tests that we can do. This is called a lower tail test. Here's why. Right? You want to know if it's less than 95. So if you have a normal distribution, which is generally what we use it, we're going to be using normal MT. We kind of test it in this region here, if it's less than 95. Right? The second option is what we call a upper tail test. So you want to see if it's in the more than region. What type of test is this? The tail. Well, pay attention in class. It can either be less than or more than. The trick in this is when they the way they word it, you have to figure out what they are testing against. Right? Because this will always be equal, but you have to figure out which one. Are you okay with that?
If it's not 8-0, it's check out.
If it's
It's not.
yeah, so if it's not 8-0, you go with 8. So if you do your test and your calculated value falls inside here, then we just go with this. Just like chi-square. Just like the chi-square test. Everybody okay with that? Alright. Take us down now. This is generally the steps in doing a hypothesis test.
I'm gonna return to.
Yeah, or
Um,
I'm gonna zoom in a little bit. That's it. Right, so when carrying the hypothesis test, we need to know these 6 things here. 6 or 7. What's the last one?
so that's the.
Okay, I'll chant that as a 6 there for this. Right, go ahead. So again, I want to highlight here that this is exactly like chi-square. Write here H0, write here H1. Right, determine what H1 is. Consider your distribution. Right, assuming it all is true and so on. Right, so these are the steps that we take in here. Don't worry with that part from people. Let's start from 1. right? So this is a general thing, but this is like kind of exactly the steps I would take in chi-square, right? So done? Oh, one more, right? Number 7. What's number 7? Ethan, what's number 7? You answer. After you perform the calculation to finally test in the critical region, what you will do? Right, you go to the conclusion. If it's bigger, if it's outside the region, you have to set if it's inside here. You check. So the last step is the conclusion. No, TFA. Last one. Make a conclusion. By result. Results. Yes. Give a little space and come back now. Answer. Well done.
What?
We've done 6.
Oh,
Oh yeah, we're just getting a couple of examples. Done. All right, amen. Done.
I still see it right together.
All right, well, the last part is conclusion. Right. Here's something that we need to know all of. Whenever we dealing with a normal distribution, right? Let me see if you all remember this from about 2 months ago. Might not happen, right? Might not remember, but remember, and something I wanted to note, right? That every time we testing each node, we are testing to see what the mean is, right? Whatever that is. Testing this, right? So which sample, anybody can answer, what sample distribution we're going to use? Huh? What sample distribution? Sample distribution of what? Of means. We're going to use sample distribution of means. So it means that we're going to use X bar. Right? Right? Most of them will come from a normal. What was the mean? The mean was mu. No, I ain't giving no values. The mean is mu, but the variance is what? Right? The variance is sigma squared on root 10. So regardless of what normal distribution it comes from, this is what we use it. Right? Huh? No, it's n. Push up. Sorry, voila. Root 10 is standard deviation. Sorry. Right, and one more thing, how we get the test value, right? So add this to your notes, please. You don't need this, right? You're making note of this? Let's do a little sketch on lower tail, upper tail, two tail tests. You don't have to tell them lower tail or upper tail. Right? So what's here? Just like how you had a formula for chi-squared, you have a formula for the test value for z, right? X bar, that's some sample. Mu naught, that'll come from the population. Sigma and root 10, that comes from us. Okay? This is the value that we're going to test against, the critical value that we find. All right? So we're going to do an example and run through all the steps in that example. All right, online? So basically, what we're doing for those who are now listening, right? Right? What we're doing, we're going to do a hypothesis test. We're going to develop each node, each one. We're going to use the right distribution, find the critical region, get a test value, make a conclusion. All right, online level, let me see who most likely not listening. Annalise listening. Devana listening. Matthew, what Matthew symbol there? No, he not listening. What's that gold chain? Matthew, alright. Sophie there, Stefan doing the work for sure.
No, Stefan not doing it.
Now, Stefan.
Or we too.
Looking at a little hard there. Again, thing from Kaylee but Kaylee and those who do in the SB are adding your to group and sending you a sample, right? All we doing is chi-squared and a pressure, and that's it. Short SB, take it like a little 2 days and get right up. I just waiting on a few others to send a message who did not reply. But I have the list now. Ready? So make sure you remember this and make sure you know what test you're using, right? And let's jump into an example. You will need tables, right? Using this you put it. Telephone. Huh? It's in the group. So let me go up our extra today.
Yeah.
I'm scared to watch.
So if you
I used to back about by the something.
like them some people.
Something I like it. And I do one down.
Yeah.
Everybody ready? Let's go now. Let's try one. Each year, students write an exam called Applied Maths. Each year, students write an exam called Applied Maths. Over a period of time, over a period of time, over a period of time, it has been established. Over a period of time, it has been established that the marks can be modeled by a normal distribution. That the marks can be modeled by a normal distribution. By a normal distribution of mean 70, and standard deviation 6. And before we move on, those values belong to a population or a sample population, right? Right? So stuff. This year it was taught This year it was taught, what's the mean was again? 70 and standard deviation what? 6. This year it was taught that the students, this year it was taught that the students from a particular country, I now see in this child. But is somebody new? I didn't see that person. Right. This year it was taught that the students from a particular country did not perform as well. Full stop. The marks of a random sample. The marks of a random sample of 25 students from that country the marks of the students, sorry, the marks of a random sample of 25 students from the country was scrutinized, were judged, were investigated. And it was found that their mean mark was, 67.3. 67.3. Right, question. This 67 here. This value here. It can be sample and population. Sample, right? Question said sample. So X bar and N is how much? 25. Nice. Full stop. Does this provide evidence? Does this provide evidence? And I'm trying to put it together to make sense. Does this provide evidence at the 5% level? Does this provide evidence at the 5% level that the trainees from this country, sorry, students, that the students from this country did not perform well as expected? Did not perform well as expected. That's it. Ready? So we're gonna go through it step by step, right? Right, before we start writing, let's just make a note of what it told us. They told us that it came from a normal with mean 70 and variance what again?
6.
Or standard deviation? What did they give us? Standard deviation 6. Right? And then they gave us some sample information, X bar. They said X bar was 67.3 and N is 25. So what do we know? We know that our distribution X bar is a normal with mean 70 and variance 6 squared on 25. You can write it like this, 36 on 25. It's up to you. Everybody clear it up? That's how we know. Right? Next step, Mikhail. H naught H1. H0 is always from a population data. So mu is what? 70. We tested to see if mu is 70. Grade 1 will be H1. So what's the test, right? So you want to see if mu was actually less than 70, right? Because remember they said they found that the people perform badly, right? So that's the trick. The trick is to really get this. Read the 84 and make sure you get it. Well, once you get this, that's easy. All right. So because we want to see if they did poorly is this. Suppose we wanted to see if they outperform. Then it'll become greater than, right? So we know, sorry, all right, it's here. So we know that we're doing a lower tail test, right? So lower tail, because it's normal, is somewhere down here, right? What's the significance level? 5%. So this here has to be 0.05. Anybody remember how to get this critical value here?
It's 1 month.
Okay, right. So basically, we know that this is equivalent to this. Correct? These two are the same value, right? It's still symmetrical. So now all we have to do is to find phi inverse of 1 minus this. Right? So you have to go back to the table and find phi inverse of 0.95. Right? And that will give us a critical value of what? Back to the table and check them out.
Singles details on this.
Hmm?
You give me p-value. Then
Well, that's technically what it is. I don't know if all of them do give it to you. Some of them may still have to go and read it all. Some of the sheets that you all get have the p-value. But the old ones do have it. So you gotta go and work it over. Check and see what corresponds to 0.95.
double means
Right. 1 point. Very good. But the problem is, what do we know about this value here? Is this value positive or negative? Negative. So it's negative 1.645. So what will it take for us to reject now? Reject H0 if what? If the Z value we calculate, that's using that formula there. If the Z value we calculate is trapped in this region. So it means that Z calculated is less than minus 1.45 minus. That makes sense? You're with it? Come back. You okay with this?
yes,
So all we do watch, right? I know you're zoning out there. Lower tail test, right? We have to find the critical value that corresponds to 0.05. So you went to the table, we found 1 minus, and we got this value. Because on the left is minus. So we know that anything less than that value will be cause us to reject H0. Right? So this is the value that we're going to test it against.
take a unique p-value.
Huh?
It is a unique p-value.
This sometimes is called, this is what it is called p-values. So the p-value for 0.95, of course. How is lower? Yes, go to the table. Go to your table and look for 0.95 and see what values correspond to. Look for 0.9 or 0.499 and then add on 495. Right, so look for 0.945 and then forget add one piece up. Find it? Find it, but it's not one. So you look at this, you will give you 0.9. Little system here,
Yeah.
right? And then 1.6.
Yes.
Well, this, if they give it to you, but if not, that's what you have. Everybody okay with us? Right? What's the next step? Next step is to find the calculated value. Find it from an up, please. What's the formula we using here? What's the formula we using for the calculated value? Right? X bar, you gotta be careful here. X bar, we find it already. We know what is mu naught. And we know what is sigma and root 10. Tell me what you got. That's the end of my mark right there. Well, I set my markers in here and change my markers. Oh, it's the class. I find something. After I'm inside it, people want to out. I have it, I'm done. I got some. Wait now. Security going on.
Yes. I first think I
The rules, the mother rule. No, I don't want to. I don't protest it for look pay me. Oh, then I don't protest. X bar is how much? 67.3. Mu naught is 70 and sigma and root 10 is the square root of this, right? Square root of 36 and 25. Right? 6 squared. Well, no. If you write sigma and root 10 is 6 on root 25. Same thing, right? Right? This is what is square root of. Right? The square root of 36 on 25 is the same as 6 on root 25. Same thing. Same. Minus 2.25. So, what would you do, Joseph? The value that we get for Z calculated minus 2.25. So, do you what do we do? You reject. So, we're going to reject H naught because this is less than this. Reject H naught. Oh, yeah, this is very important. Yeah? Huh? Yeah, that's H naught. Right? Reject the H naught at the 5% level. You have to write this. Because if I change the level, the test, the final part of the test could change. The conclusion could change. So you have to write this, right? At the 5% level. And conclude that the students did do that the students, and always relate to the question they give you, right? Students perform poorly from that country, right? So what do you mark there one? And I said that is all I just got. Sorry? Yeah, you'll do some. That's a mark conclusion. So you kind of just reach here and get clear and move on. Right? The purpose of the whole test is this. So you will lose a mark. I expect them to make a conclusion for you.
So I can't tell again what I'm asking. The whole question I can get the conclusion.
Yeah, can't leave out that. There's like a hypothesis test.
Like 2 points.
You do all this and then you do right. The last step again, but that's actually just more important than that. That's okay. So all that difficult in this is which one it is. All right. Let's see if we can at least do a lower. Let's see if we can do. What difficult? You're always using this to test the value. Yeah, just the what might confuse if you're learning work is just one. The word in it. That's easy enough. Well, you good? You good to go. And again, just like confidence interval, what would you do if the sample is large? But we didn't tell you it was a normal. What you would do? Approximate by CLT, right? What would happen if the sample size is small and you don't and you have an unknown variance? What you do? T, right? So the same rules that you would have used in units in confidence intervals, you had applied them here. Same rules. All right? Right. Quick question before I give you the next one. What would happen if it's a two-tailed test? Suppose they said they want to see if the marks obtained was not equal to 7. What would change in this whole process? They can't include, well, obviously, but what else? What else will change? We're still testing at the 5% level. Right, the calculated value will stay the same as the critical region, but that's theta for both sides. So if you want to be 95% correct, then you're going to be 5% wrong. So how much is here? 2.5. But okay with that? So you're going to change now. You see how we went to the table and we worked out for 1 minus 0.05. Now we're going to work out for 1 minus 0.025. That's okay? That's it. That we just not focus on this and part. I just really focus on margin. Which I can keep that. Yep. Well, yeah, that's right. Put it on the internet.
How much more work is key physics and systems? Like 2 times the amount, 3 times the amount.
How easy it is we might think that. Because how easy is 6 seconds.
PORs of adults.
1.5. Right. Not much. And apply the one exam, the other work in and work out. Alright, let's go now. Let's try the next one here. What? Well, I guess
No, I get it. Yes, I get 68. I get 12. So then I get you below us. Many class, I get 7.
Online, okay there? So I'll give all the other minute break. Try this one here. I'm taking a picture. Right, we're not doing fast paper. All of these are from the textbook.
Another.
Vai lá. Come fare a casa? No cars. Yeah, I got something now. We are fed up with this. Wait, 14? What? Try this again earlier. Do the opportune test first. Do B and then E. Do every words on the scenario, right? We're just using these and just a practice calculation. Right now I can't find after the But B first, huh? Yeah, yeah. Okay. B first, olha.
Esse era after.
Nós do bolso, né, na verdade, das coisas.
What do you call that? What do you call that? Yeah, sure. Sure. You might have seen the shoot. Double check. You might have seen the shoot.
At the level, at the 5%.
Yeah. Wait. Yeah, no, I just want. You checking. Check it out. Okay, yes. This week, I see how much. Yes.
Right, I got check out. You right?
No, I'm not with the follows, fine, it's with the agent.
Right, so your mu naught for this one is 26.3. Your standard deviation is 1.2. Right, your X bar is 27 and your N is 10. Because we. Right, let's check it out and I from this. Right, so the mean is 27 and this will be 1.2 squared over 10. Right, we're testing to see if it's 26.3, less than or more than? More than 26.3. Huh? So it is a upper tail test. Right here. Right, it's an upper tail test. Right, and it's the same thing, same 5%, 0.05. So basically it's the same test, same critical value, which is 1.645. So we're going to reject H naught if the calculated value is more than 1.645. Oh, obviously, so X bar is 27. The value we testing against is 26.3. And remember, we square rooting this up. We square rooting 1.2 squared over 10. Or you could write it as 1.2 and root 10, don't matter. How much here? 1.845. So we're going to reject H naught at the 5%. Okay. Or we can do the next one for homework up and now.
Yeah.
Huh? Finish already? What you end up doing? What's the calculated value? That's the value that you, this is the table value that we tested. Right? Yes, one thing I want to remember for the two tail, for those who didn't do it or finish it already, the two tail is a test that looks like this. Right? So it means that here and here is 0.025, same thing on this side. So the value that you're looking for is pi inverse of 1 minus 0.025, which was how much? 1.96. So your critical region will be anything more than 1.96, anything less than 1.96. Okay, it will be either one. So once it falls more than or less than, you check it. Right, and then they come here and they do a calculated value. What's X bar? 15 points. Anybody confused online? The one I have here was the one was part B, and this is part A now. It was 15 points. 15.2 minus what? All over
Trigger lights.
square root of, and you got what?
And it's 1.0.
1.095, so you do not reject.
You say we do not reject the null or we do not cancel.
You can say all that, guys. This do have a scenario, but just put at 5%. Okay, so you reject the first one, part B, and you for part A we do not reject. Right? Please do not remember. Please remember. What's it? Please do not remember. Please remember to when it's a two-tailed test to split the significance level, right? That's okay. Right, so we're just going to add on more conditions next week. Couple Joseph? Yeah.
When it is rejected.
Here's reject if this value here less than 1.96 or more than. If it is either side. What some books will write is modulus. So if the modulus of your value is bigger than 1.96, you reject. The modulus of this is less than 1.96, so we go.
So this is not next week, this thing is.
Yeah, because we could do an different passage for that.
What time?
No, it's that's all here. You have to do three to wait, not 3 to 8.
I said.
Or you could do 3 to 6, or you could do 5 to 8.
I say it just.
Or you could decide, right? And ask online, right?
No, shit.
No. The only teaching I'm doing is from normal time before it past papers.
Yeah.
Right? So we do the past papers and then I do Right. Just remember the message on the right.